The writer online is lesson is Prince Papa Tony, the teacher. A-level students, look at some of the trigonometry formula for sine, for triple angles of sine. When you look at the problem, it says prove that sin 3x is equal to sin x cos squared x minus sin cubed x, or prove that sin 3x is equal to sin x minus 4 sin cubed x. So when you look at this is sine triple angles. So what are we going to do? Before you do anything, you first derive the compound angle formulas. So an example, sine A plus B can be given as sine A cos B plus cos A sine B. Then let us also look at double angle. Sine 2A can be written as 2 sine A cos A. Then the double angle for cos can be written as cos squared A minus sine squared A, or can be written as 2 cos squared A minus 1, or can be written as 1 minus sine squared A. You look at cos, all these formulas can be derived for the double angles of cos. Now let us go to our problem. The problem says 3 sine x is equal to 3 sine x cos squared x minus sine cubed x. They want us to prove whether this side is equal to the other side. Once you have two sides and you want to prove that one side is equal to another side, we have left hand side, this is right hand side. You always pick one side and then you prove it to see that is equivalent or is equal to the opposite side. Now let us, using the left hand side, sine 3x can be seen as sine 3x can be written as sine 2x plus x. So a triple angle can be broken into this is equivalent to, now go back to the compound angle formula. Sine 2x plus x can be seen as sine 2x cos x plus cos 2x sine x. You see that this and this, they have a relationship. Then let us also break the double angles in our task. Sine 2x can be written as 2 sine x cos x. Don't forget we are having a cos here which is multiplying sine 2x, because sine 2x only is 2 sine x cos x, then times, that is not a decimal point, this is a times, cos of x plus. Now sine 2x, I may decide to take sine squared x, cos squared x minus sine squared x. So put them in the brackets and then multiply them by sine x. Alright, now let us try to expand our task. Sine x times cos x times cos x, this will give us sine 2 sine x cos squared x plus sin x times, we are opening the parentheses, so we are expanding them, sorry, removing the brackets. Sin x times cos squared x, this will give us sin x cos squared x minus sin x times sin squared x, it will give us sin cubed x. Now look at the first two terms, 2 sin x cos squared x plus sin x cos squared x, they are like terms, therefore combine them. In combining, we look at the coefficients. We look at their coefficients. 2 plus, this one has invisible coefficient of 1. It will give us a 3 sin x cos squared x, then minus sin cubed x. Now, when you look at this, is the same as this. 3 sin x cos squared x minus sin cubed x. So we have proved one of the side, this one, and is equivalent to the left hand side. Therefore, I have exactly what is on the right hand side as required. Now, the second one, they want us to prove the same sin 3x is equal to 3 sin x minus 4 sin cubed x. You see that this one, there is nothing like a cos. Everything is in terms of sine. Therefore, from where you stopped, because the procedures will be the same from the start because of the triple angle. Therefore, what I'm going to do, from where I stopped, I may substitute cos squared x for I may substitute this for 1 minus sine squared. This will give me 3 sin x, no, cos squared x, okay, cos squared x can be seen as 1 minus sine squared x, close the brackets, then minus sine cubed x. Someone may ask me, sir, where did you get 1 minus sine squared x? Don't forget that from the identity, sine squared x plus cos squared x is equal to 1. So I have to make this the subject, meaning that I'll transfer this side. Therefore, cos squared x will be equal to 1. When it crosses the equal sign, it will become a negative squared x. You see that wherever I find the cos squared x, I'll substitute it for 1 minus sine squared x. Therefore, in opening the parentheses, this will give us 3 sin x times 1 gives us 3 sin x minus 3 sin x times sin x. This will give us 3. This will give us a 3 as sine cubed x, then minus sine cubed x. Now, look at the two last terms. The two last terms, they have a common, they have a like a term, or they are alike. So we add their coefficients, -3, -1, it will give us -4. Therefore, our last step will be 3 sin x, -3 minus 1, this will give us -4 sin cubed x. Look at this term and then the term which was given to us. 3 sin x minus 4 sin cubed x is the same as what we have on the left hand side. Therefore, this side is equivalent to right hand side as required. Thank you for following Principal Patone, the teacher and the writer. A-level students, don't forget the rules and then the principles of compound angle formulas and then the double angle formulas.